A ratio is a comparison of two quantities. So if I say I have 5 blue squares and I have 1 red square, you're basically comparing the number of blue squares to the number of red squares, and you do it through a ratio. So whatever they list first is going to become the numerator, and whatever they list second is going to become the denominator. So for this one, it's going to be 5/1. If they were to say 1 blue square to 5 red squares, then you would put 1/5. So the first thing goes first. So this one.
I have a question.
Yeah.
So if it's like 5/1, can it be 1/5, or is it always the same?
So it always has to be whatever they say first. They'll say, like this one is yellow counters to red counters. It has to be 1 to 2 or 1 to 2. These are, or you could say 1 to 2. It has to be first thing is first, list it. First thing is numerator. First thing is first, list it.
Okay.
So if you
is it
put,
wrong if you
yeah,
don't do it? Okay.
Yep. So if the question was there are 5 blue squares to every red square and you put 1 to 5, that would be wrong. 100% wrong. You wouldn't even get it right at all. It's 100% wrong. So you put the first thing. This one is yellow counters to red counters. So you would count 1, 2, 3, 4, 5. So it'd be 5 to 3, never 3 to 5. And then because they're saying write the ratio of yellow counters to red counters, if they did this one, 3 to 2, the 3 automatically means yellow and the 2 automatically means red because it has to keep the order. So you would draw 3 yellow counters or yellow circles, and you would draw 2 red circles. Does that make sense to you? So the biggest thing to remember is order matters. So this one is 3 to 2. And they tell us what the order is. We don't decide. For this one, it's 1 to 5. So it'd be 1, 2, 3, 4, 5. And we would show it like this. 1 to 5, 1:5, 1/5. Those are the 3 ways to show ratio. Do you have any questions about that, honey?
No.
Okay. So this one is write the ratio of gray counters to white counters. And then they put gray and they put a colon white and then they wrote it out. That's 100% fine. So they counted the number of grays and then they counted the number of whites. So what would number 2 be?
It would be 4 to 1.
Yep. And number 5, what would you draw?
Draw 5 gray and then 1 white.
Exactly. All right. Okay. Then you might have some word problems. I know Catholic schools are big into those word problems. So let's just do a couple of those. Francine is making a necklace that has 1 blue bead for every 6 white beads. So the ratio would be 1 to 6, 1 to 6, 1 to 6. You can write it any of those ways. So they want to find out how many white beads will she use if she uses 11 blue beads. So the best way to do it is to say blue, white, 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 because the ratio is 1 blue and every 6. So this is 1, 2, 3, 4, 5, 6, 7 beads so far. And we want to find out how many she would have if she had 11 blue beads. So we don't have to write all this out. We can just do, that's too much, right? We would have to count and keep counting and keep counting. So instead of writing it all out, we know that for every 1 blue bead, there's 6 white beads. So if you use 11 beads, how many white beads would she have? What's your guess?
Are you saying if there's 11 blue beads, there's, so, is it you like just say a number or you have to like do diversion and stuff?
So it says how many white beads. So you're going to have a number and then the words white beads. That's going to be your answer. So the answer is going to be blank white beads. So I will show you what to do. So if it's 1 to 6, and this is blue and this is white, and we want to know how many it would be if there were, not multiplying, if there were 11 blue beads, right? How many white beads would there be? We're basically making an equivalent fraction, which means if we turn this 1 into an 11, remember how when we're adding or subtracting fractions, we have to make an equivalent fraction. So we go like this, times 11, anything I do to the denominator, I do to the numerator. That's what you're going to do here, and that's what's going to fill in the question mark. So if the ratio is 1 to 6, anything I do to the numerator, I would do to the denominator, and anything I do to the denominator, because the fraction has to move together. So if I did something to the denominator, I'd have to do it to the numerator. And if I do something to the numerator, I have to do the same thing. So ratios move together as one whole. Anything you do to the top, you do to the bottom. Anything you do to the bottom, you do to the top. So if I change this 1 into an 11, I have to multiply this by 11. Then I have to do the same for the denominator. So my denominator is 66. And that's the number that I'm looking for. How many white beads? 66. Does that make sense to you, or does that not make sense to you?
No, it makes sense. I think we did that in class now that I think about it.
Okay, perfect. So let's try another one. So a basketball league assigns 8 players to each team. Oh wait, that's not the same type of problem. Okay, you might have something like this as well. So of the 24 students in Greg's class, so there's 24 students total, 3/8 ride the bus to school. How many students ride the bus? So you're going to do 24 over 1, because you see that this is a fraction, right? And then you're actually going to multiply 3/8 by 24. So 24 times 3, you're just going to do this, is 72 over 8. And then 72 divided by 8 is 9. Does that make sense to you why I multiplied, or does that not make sense to you?
I don't understand why you're dividing.
We're not dividing, we're multiplying right here. And then the reason why we're dividing is because this is an improper fraction. Remember I talked to you if the numerator is bigger than the denominator. Yeah. So we have to turn it into a mixed number, but it's not a mixed number because it goes in evenly. So it's just 9 students. So most people don't understand why you would multiply something like this. It doesn't feel like multiplication. So let me show you when you multiply a fraction with a whole number like this. If you have a total number of something, so suppose the number's 50. There's 50 people on a bus. And you're saying you want to find out some piece of that. 1/4 of them have to go to the bathroom. When you're trying to find a piece of a total, you actually multiply the whole number with the fraction. Like this. Because you're trying to find a piece of a whole. So if I had, you would actually do it for a fraction as well. So if I have, suppose mom bought a pizza, and here's the whole pizza, and then you and your brother ate half the pizza. So this pizza is what's left. And now your mom says, so we have this much left. And your mom says, okay, guys, you can equally share what's left. You would split it into however many pieces you guys are going to split it into. But to figure that out, you would say 1/2 times 1/2. So you have half a pizza left. This pizza's gone. That's why I rewrote it here. And then you're going to now share this into half, right? You're going to get half and your brother's going to get half. So each of you are going to get 1/4 of the original pizza because you multiply. And then if you look at this, isn't this 1/4 of a pizza? So this is yours. And then what's your brother's name?
Colin.
What is it?
Colin.
Colin. Okay, so anytime you have a total or you have a fraction of something and they want you to then figure out what the fraction of that is, you always multiply it. So this one right here was 50 students total and you're breaking it into pieces. That's a whole number times a fraction. This one is a fraction of something times a fraction as well. So when they tell you there are 75 marbles and you're going to take half of those marbles, same type of problem. You have a total number of marbles and you're going to split it into a fraction. Does that make sense to you, or is that still confusing?
It makes sense, actually.
Okay. All right. So they're saying use these or write these ratios in two different ways. So if I told you that there's two ways to write it besides this. This is the first way. The other way is like this, and then the other way is like this. So you can write it with the word 2. You can write it with the colon, or you can write it as a fraction. So if they've already written it this way, we would have to write it this other 2 ways. If they write it like this, we would have to write it with a colon and with the word 2. Does that make sense to you? Okay. Have you gone over rate and unit rate?
No.
Okay, that's probably what you're going to do next. So a rate is almost the same exact thing as a ratio. So what it's saying is, for example, if you have, let me get a good, Okay. If you spent $50 and you bought, so this is what you spent total, and you bought 10 shirts. To find the unit rate is basically asking how much was one shirt. So you're going to divide it. It's going to be 50 over 10, and then you're going to divide 50 by 10. So it's going to be 5, and we're trying to find the unit rate, and in this case, the rate is in dollars. So it's going to be $5 per shirt.
Oh, wait, I think I did that on my homework today.
Okay, perfect. Yeah, it's the same. It's totally like a ratio. Same type of process. Okay. The next thing that you might have already done or you will do is to find equivalent ratios. So an equivalent means equal.
Oh yeah, I've done that.
Okay, good.
So
So you want to find out two ratios that are equal to 3/8. You're either going to divide the numerator and denominator by something, or you're going to multiply it by something. The only rule for this is that whatever you multiply the numerator by, you have to multiply the denominator by, and vice versa. Because remember, fractions move together. So you can't divide this by 3 and divide this by 2. It has to be the same number. So if you multiplied it by 2, you'd have to multiply this by 2. If you multiplied it by 5, you'd have to multiply this by 5. If you multiplied the numerator by 3, you'd have to multiply the denominator by 3. So 3/8 was our equivalent. We're trying to find equivalent fractions. 6/16 would be an equivalent fraction. 15/40 would be an equivalent fraction. And 9/24. These are all equivalent fractions to 3/8. Does that make sense to you?
Yeah.
Okay.
It's a little confusing, but yeah.
Yeah, so multiplying is the easiest. You can also simplify or divide, but multiplying is easy because you don't even have to find a common number that they both divide into. You could just multiply by anything. And then they might ask you to compare, is 2/3 equivalent to 5/6? So they're asking, are those equal? So in this case, I would say, well, I can change a 3 into a 6. What would I have to do to change my 3 into a 6? I would have to multiply it by 2. And I know fractions move together. So if I multiply this by 2, I have to multiply this by 2. And then I say, is this true? Is 2 times 2 5? No. So it's not an equivalent fraction. If the number comes out to be true, then it is an equivalent fraction. So is 8/3 and 32/12 equivalent fractions? So we don't know. We're going to change our denominator into 12. How would I change my denominator into 12? I would multiply it by 4. And then anything I do to my denominator, I have to do to my numerator. And 8 times 4 is 32. So is that what they said?
Yeah.
So then these two are equivalent fractions. Does that make sense?
Mm-hmm.
Okay. Let's see.
So as long as you can make the same as the other one, they're common.
Mm-hmm. If it doesn't turn out to be true, then they're not equivalent.
Okay.
So is 4/10 equivalent to 5/40? So we're trying to find out. So I'm going to put a question mark there because we don't know, right? What I'm saying here is 4/10 is equal to 5/40. Is that true? So then how would I change this 10 to a 40? I would multiply it by 4. Anything I do to my denominator, I do to my numerator. Is 4 times 4 5?
No.
No. So it's not an equivalent fraction. If they asked me, is 4/10 and 40th 100ths equivalent fractions, then I would say, okay, if I had 10 and I was changing it to a 100, what would I multiply it by? I would multiply it by 10, and then anything I do to my numerator, I do to my denominator. Is 10 times 4 40?
Yes.
So then that is an equivalent fraction. This one is not. Okay. The last thing that we'll do, that is probably the last type of problem that you'll do. So you got to stick with me for this because it's a little confusing, but if you watch the video and you break it into pieces, then it will totally make sense. So during migration, a hummingbird can fly 210 miles in 7 hours, and a goose can fly 165 miles in 3 hours. Which bird flies faster? So for this, we're trying to find the unit rate. We're trying to find what each bird flies in 1 hour. So what I'm going to do is I'm going to take the hummingbird. So the hummingbird flies 210 miles in 7 hours, and the goose flies 165 in 3 hours. So I'm going to divide this. I don't know if you can use your calculator, but I'm just going to use my calculator for here. We have 210 divided by 7 equals 30. So that means he goes 30 miles in 1 hour, and the goose goes 165 divided by 3. The goose goes 55 miles in 1 hour. So then we can see, okay, who goes faster? Is it better to drive 30 miles in 1 hour? Or not drive, it flies, but like if we're driving, would you get somewhere quicker if you drove 30 miles in 1 hour, or would you get somewhere quicker if you drove 55 miles in 1 hour?
30 miles in 1 hour? No, wait, 55. No.
Yeah. So then we know the goose flies quicker.
I didn't look at it good enough.
What, honey?
I didn't look at that good. I just...
Okay. So let's try. Does all of that make sense? Do you need me to re-explain? I did a recording so you can watch it over and over again, but does that kind of make sense?
Yeah.
Okay.